Hi there, folks. Today we're looking at volumes of pyramids and cones. And the formula for the volume of a pyramid or a cone, because again, they're essentially the same thing, but one is not technically a polyhedron. That's our cone because of the circular nature of the base. But either way, for the volume of this thing, the volume is 1/3 the area of the base times the height. Okay? And so once again, that capital B indicates the area of the base. This time, the height is the actual height of this thing, so measuring from that point at the top perpendicular to the base. We're not talking about the slant height this time. It's not L, it's H this time, so the actual height of this thing. So measuring from the base directly to the top of this thing, okay, directly to that point. For example, if I look at something like this guy, it says find the volume of each. And so for this one, the volume is 1/3 the area of the base times the height. And notice the height is the thing that's given here, all right? Not the slant height. The actual height of this thing is when we measure from the base and we measure perpendicular to the point that this thing kind of converges at. And so for this one, once again, I do volume equals 1/3. The area of the base this time would just be the area of this square that's at the bottom, which is a 4x4 square. And so for this one, 4x4, that's a 16 square feet for the area of the base of this thing. So the area of the base is 16. And now times the height, and the height of this pyramid is going to be a 6. Okay? And again, this is a job for my calculator, so I plug it in. That gives me a 32, and that's cubic feet. Okay? If I look at the next one, once again, I want to do 1/3 the area of the base times the height. So volume equals 1/3 the area of the base this time. The base of this thing is a circle. And so to find the area of a circle, remember it's pi r squared. So pi times the radius squared. The radius of this one is going to be 15. So that's a 225 pi. Once again, I'll leave it in terms of pi. I'll actually do the entire volume in terms of pi, and then I'll write the thing as a decimal just to kind of show both versions of this. So the area of the base this time, that was 225 pi. And now times the height. Be careful here. The value that's given is actually the slant height. That's not the actual height of the cone. The height of the cone is when we measure from the base perpendicular to the point. And with this one, that's the slant height that's given. So that 25 is the L value. We want H. And so the way to approach this is we have to kind of use this right triangle that's here. Okay? I know the base of this right triangle down here is 15. I know the hypotenuse is 25. I have to do my Pythagorean theorem here and look for this H value, this height that I'm missing, okay? And so if I take this thing kind of off to the side, it's H squared plus 15 squared equals 25 squared. And at this point, we should be pretty good at our Pythagorean theorem, so I'm just going to go ahead and plug this right into my calculator. Looks like I get an H value of 20 when I solve this thing. And again, I just do the 15 squared as the 225. The 25 squared is the 625. I subtract the 225, and then I have to take the square root to find this thing. And so for this one, that's my actual height when it's all said and done. Okay. So again, make sure you're dealing with the height, not the slant height this time. The height of this thing is 20 centimeters. Okay, and now the rest of this is a job for my calculator, the 225 times the 20, and then divided by the 3 or times the 1/3. And again, I'm going to leave this in terms of pi. That's a 1,500 pi cubic centimeters. And so that's my exact value for the volume. If I wanted the rounded off value, again, I use that pi button on my calculator, plug it in, and I get 4712.39 cubic centimeters. Okay? So it really depends on the question. If it asks for the exact volume, I leave it in terms of pi. If it asks for a rounded off answer, then I plug it in. Okay? If I look at this guy, once again, I'm missing the little box here, but let's assume that it was supposed to be there. So that is the height of this pyramid. This is a hexagonal pyramid this time. And so for this particular example, I have to find the area of the base, which is that hexagon. And so once again, this comes down to we'll assume that this is a regular hexagon. Okay, so all these are 6 feet. In order to do the area of the base here, well, the area of this base, sorry, I don't need to write all of these. We can all see that they're 6 feet. But the area of the base of this thing, well, that's 1/2 the apothem times the perimeter. Once again, I don't have the apothem this time. I do have the perimeter at 36 feet. And so the apothem this time, again, if I kind of take this thing off to the side, let me draw this hexagon off to the side. And I didn't do a great job drawing a regular hexagon, but that's okay. If you kind of start to break this thing down, once again, this is kind of the thing we're looking for. So we're looking for that value right there, the apothem. Once again, if we're looking at something like a regular hexagon, the angles inside of a hexagon add up to 720 using my formula, which means then that each angle is 120, which means then, so like one of these guys is 120, which means that this little piece right here is 60 degrees, making this thing a 30, 60, 90 triangle. And now I know if this piece is 3 feet, because the whole way across was 6 feet, I now know that the apothem over here is going to be 3√3 feet. Okay? And so I have to kind of go back to that idea of using what I know about regular polygons, finding the angles, using that to find the apothem. And I might have to even use my trig functions in some of these. This one happens to be a special right triangle. All right, but I might have to use my trig functions at some point. So keep that in mind, okay? And so here's the area of the base is 1/2 the apothem times the perimeter. I'm going to leave this thing in terms of the square root. There's no sense in plugging this in and rounding it off because in the greater context of this thing, I want the volume, which is 1/3 the area of the base. And it's better to have an exact value here for the area of the base. So I plug that in and I get 54√3 for this thing. So that's the area of the base. Again, if I leave this in terms of the radical down here. Okay, that's where that 54√3 comes from, just doing the 1/2 times the 3 times the 36. And then times the height of this thing. The height was actually given to me. It's that 9 feet. And so now once again, I can plug this into my calculator. If I leave it as a radical, that's going to be 162√3, and that's cubic feet. If I rounded this off as a decimal, that's going to be 280.59 cubic feet. Okay, so again, depends on the question. This one, when we're typically finding the volume of this thing, it makes more sense as a decimal, but it made a whole lot more sense to leave this guy in exact terms until I got to the end, okay? And that's why we always deal with what's the exact value, what's the rounded off value. Because sometimes using the exact value is important, especially if we need to reuse that measurement. And the rounded off value gives us kind of a better sense of this thing in a real-world context. If I look at something like this guy, it says find the volume of this thing, and notice I have a can of beans with a party hat, of course. Why we'd want to find the volume of the whole thing, I don't know. But the fact remains I've got the can of beans with the volume, with the party hat on. I want the volume of the whole thing. And so what I really need to do is I need to find the volume of each piece of this thing and kind of combine them together. Okay, and so for something like this guy, I want the volume of the cylinder. So I'll say the volume of the cylinder here. And so the volume of the cylinder, remember, is the area of the base times the height. The area of the base this time, so the base of the cylinder, I can't see the whole thing, but I would know that the area of the cylinder on this guy would be a circle. And the radius of that circle is actually a 1.5 for this one. Okay. So let me take that off to the side. So the area of the base is pi r squared. So it's a 1.5 squared. And so the area of this thing, if I kind of simplify that guy, that's going to give me a 2.25 pi. And again, it makes more sense to leave it in terms of pi for right now. So that's going to be the area of the base times the height of the cylinder, which is 4.5. And so the volume of this thing, let's see we're just going to plug this into our calculator. That gives me a 10.125 pi. Again, I'm going to leave it that way for now. And now I need to find the volume of this cone. And the volume of the cone is 1/3 the area of the base times the height. What's nice about this one is the base of this cone is the same as the base of the can of beans here. And so when you kind of look at this, the cone versus the cylinder, they share the same base, okay? It's kind of put these things together. Their base is the same circle. So I already have the area of the base for this one. It's the 2.25 pi. Didn't quite give myself enough space there. And so I don't even need to work that out again, which is nice. And now times the height. And notice, when I kind of look at this measurement, that is the overall height. That's the measurement from top to bottom, measuring at a perpendicular. It's not the slant height this time. So that's a 5. And once again, I'm going to leave this in terms of pi until I'm ready to actually add all these things together and deal with it. So let's see, 2.25 times the 5 and divided by the 3. That's a 3.75 pi. And now if I want the overall volume of the whole thing, well, I just add those volumes together. So if I add these up, if I add up these two volumes, again, since it's already in terms of pi, I can just go ahead and leave it in terms of pi for right now. So my exact volume for this whole thing would be 13.875 pi. That's the exact value, and that's cubic inches. And then the rounded off value, if I plug this into my calculator, looks like a 43.59 cubic inches. Okay, so again, really it depends on the context of the problem. It made sense to leave these in terms of pi until I got to the end. But then the final answer that I'm looking at, this is probably the guy that I really am concerned about. Okay.